Hi, my name is Tyler Anway, and I'm a PhD candidate at the University of Texas at Arlington. My research advisor is Dr. David Jorgensen, and my research interests lie primarily in commutative and homological algebra. I'd like to start by giving an overview of my two main areas of research. First, the classification of totally acyclic complexes over certain rings, and the second, the study of triangle resolutions. Before we dive deeper into each of these topics, I'd like to lay the groundwork for the setting of my research. So, first, totally acyclic complexes are the primary objects that I study, and in some sense can be viewed as a doubly infinite analog of free resolutions. If you take the collection of all totally acyclic complexes, along with the homotopy equivalence classes of chain maps between them, you obtain the category K-tag, which is where much of my work takes place. Next, the categorical notion of approximations plays an important role throughout my research. Approximations were first defined by Auslander and Smollow in 1980, and independently by Enox in 1981. Alternatively, they are sometimes referred to as covers or pre-covers, or envelopes or pre-envelopes. Simply put, approximations give us a minimal way of relating one object to another object of a specific subcategory. For example, a projective cover is simply an approximation by the full subcategory of projective modules. Lastly, triangle resolutions are an extension of the idea of resolutions from an abelian category to a triangulated one. These resolutions consist of complexes and the morphisms between them, and they are built using the idea of approximations and the axioms of a triangulated category. Now, I would like to take a closer look into the classification of totally acyclic complexes. So over a Henselian Gornstein local ring, I use indecomposable complexes as the building blocks to define the notion of Arnold tuples. For simplification of the theory, I tend to focus on Arnold tuples in the case of finite CM-type rings, since in this setting there are only finitely many indecomposable complexes. I have shown that certain structures of modules over finite CM-type rings, such as AR quivers, extend nicely to the category of totally acyclic complexes. One interesting question about this classification scheme is what information can be gained about the modules whose associated totally acyclic complexes have Arnold tuples that are very similar? Or, if their Arnold tuples are very different, does this tell us anything? Another interesting question I'm currently exploring is, how is the Arnold tuple of a mapping cone related to the Arnold tuple of the source and the target complexes? Lastly, I would like to spend some time discussing my study of triangle resolutions. So as previously stated, triangle resolutions extend the notion of a classical resolution to the triangulated category. They are built in a similar fashion to the classical free resolution, except instead of taking kernels at each step, we apply mapping cones. In particular, if one takes a complex, then approximate it to obtain a morphism, you take the mapping cone of that morphism, and by using the axioms of a triangulated category and repeating this process, we obtain a triangle resolution. In the module case, we care about the minimality of resolutions for the characteristic of uniqueness. Therefore, I am currently focused on the question, what does it mean to be a minimal triangle resolution? Furthermore, I care about identifying the conditions for which minimal triangle resolutions exist, and if so, whether uniqueness is in fact gained from the minimality. My eventual goal here is to try to adequately extend the notion of Betti numbers and complexity in order to prove certain conjectures we believe to be true. Well, that's all the time I have for now. I'd like to thank you for listening, and if you're interested in hearing more, I'll be speaking in the CHAMP seminar on Tuesday, February the 16th. I hope to see you all there.